Hi everyone, and welcome to our video on simplifying some more trigonometric expressions. So in the last video, so I'll scroll, we have it here. So we did some of these ones that still took pretty long. Okay, but our main thing is to write all of our trig functions in terms of sines and cosines, which is the reciprocal identities, and then trying to look for a Pythagorean identity to help out in certain cases. All right, and then still just try your best. Okay, so we have lots of little tips here, but I would say try your best. Okay, so there's lots of ways to do these problems. So let's break down these. So simplify the expression or each expression. So the first thing I'm going to do, let me move, because I don't like that being gray. Okay, there we go. Now I'm back. All right, so let's simplify these expressions. So first thing we're going to do is change this secant, and that's alpha. I mean, you could just pretty much do a. Okay, so but let's change that to be 1 over cosine of alpha. Okay, so the numerator looks fine. So 1 plus cosine of alpha over 1 plus 1 over cosine of alpha. All right, and then every time, so I'm putting the parentheses here. They're implied. They are always there. They just don't show it. Just like how we know there's a 1 in front of x here. Okay, we just usually don't show that 1. Okay, so anyway, let me scroll that out. Now, this is a common strategy. So we saw it in the last couple of problems too. We look at this small denominator and we want it gone. So we don't want complex fractions. So what we'll do is multiply all of this fraction, the whole numerator, by cosine of alpha and the whole denominator by cosine of alpha. And then let's see. All right, sometimes it can be nice to not fully multiply. Okay, so this right here is already factored, and I'm going to leave it factored. Leave factored. Let's see if that helps out. While the bottom, we need to distribute because we do want the fraction gone that's in a fraction. So we don't want fractions in fractions. So this cosine of alpha multiplies that 1. That cosine of alpha multiplies that 1. And then what we have here would be 1 plus cosine of alpha and then cosine of alpha. Okay, so I've got a hunch that we should not multiply that out. Even if we did, it's not a big deal. Okay, so I'm leaving it factored, so maybe I need to multiply it out and it wouldn't take very long anyway. All right, so the denominator, 1, so this cosine of alpha times 1 is cosine of alpha. Now, let's do this in a single step. So the cosine of alpha would multiply the 1 right here. And then I have a cosine of alpha down below, which means the 2 would just cancel. So we would have just plus 1. Okay, so I often skip the showing of the steps. So here, where my pointer was me showing the cosine cubed of y timesing 1, but then we reduced it anyway. So I like to try to do that in one single step once we're a little more comfortable with it. Okay, so that's how that breaks down. Now, this is why we left it factored in the numerator. This down here, we can use the commutative property. So I'm rewriting the numerator. So 1 plus cosine of alpha times cosine of alpha. And then the commutative property would be 1 plus cosine of alpha. Now, the reason I did that is to show that we have an exact match with these two binomials. And as long as it's multiplication in the numerator, like it currently is, we can cancel. So whenever you have the same thing divided by itself, it's always 1. So all of this in the highlight is gone, or it becomes 1. So 1. And then that lone cosine of alpha that wasn't highlighted is left over. Well, 1 times cosine of alpha, we don't need to show 1. There it is. Okay, so that whole thing simplified to cosine of alpha. Typically, that's how these go. They simplify pretty nice. So like this, that was messy, became sine squared. This thing that was messy was just cosine of t. This thing that was messy was just 1/3 tangent of y. Okay, so they usually aren't pretty wild answers. So this one, yeah, that's good. Okay, so if you're getting some wild stuff, it might be a sign that something went wrong and to try something different. Okay, so number 2 here. Here we've got two separate fractions. when you have two separate fractions, you usually want them to be combined into a single fraction. So that means this sine of x plus 1 and this sine of x minus 1 should multiply down in the denominator, and then the bottom right will multiply the top left. The bottom left will multiply the top right. So we have 1 times sine of x minus 1, and then plus 1 times sine of x plus 1. And let me even put the 1 in parentheses. Okay, so that would be more useful, these parentheses, if these were different expressions. Okay, so 1's nice, but whatever this is, whatever those are, I'd say use parentheses and look to distribute either way. Okay, and then the denominator, we are saying the two down there currently should multiply. So we have sine of x plus 1 times sine of x minus 1. Okay, so that's how that one breaks down. And then now let's simplify. So this one distributes. This positive one also distributes. So big fraction bar, sine of x minus 1 plus sine of x plus 1. And then the denominator is sine of x plus 1 and times sine of x minus 1. Okay, and then the numerator will, so I'm leaving the denominator factored again. So it might need to be multiplied out. I don't know. Let's find out in a little bit. But my main focus right now is to continue simplifying the numerator. So sine of x plus sine of x would be 2 sine of x. Negative 1 and positive 1 would be 0. Okay, so we've got just 2 sine of x left in the numerator, and then our denominator is sine of x plus 1 times sine of x minus 1. Now, sine of x up top is as good as it gets, and I don't think there's any reason to multiply that bottom out because nothing else is going to simplify. So usually we multiply or factor to try to continue simplifying, but this is about as good as this is going to get, and I'm going to leave it like that. Okay, so you can get a different answer if you do distribute that all the way out. I'm going to just leave it as a hint. If you do distribute, there would eventually be a Pythagorean identity that you can use, and you can get a final answer that looks a little different. Okay, so, but again, I'm going to leave it like that to be done with it. I think that's going to be fine. Okay, so if you do want to keep going with it, and you're saying, what are you talking about here? Just email me, let me know. Okay, so I can continue with it, but I'm going to save some time on this video and say we're good. Okay, so that's it for this one. If you do have questions, please let me know. Otherwise, thanks for watching, and see you again soon.